Hello everyone, this is Mrs. Lindsay. Today we're going to talk about higher order derivatives. Okay, so I would like you to go ahead and pause this and find the derivative of this function. Push play when you're ready to check your answers. Okay, so again this is just power rule, so that we have the derivative. Question, just thinking about this original equation and taking the derivative. Is it possible to take the derivative of the derivative? And hopefully, if you take a look at this derivative, your answer to this is yes, we absolutely could take then the derivative. And we would call this the second derivative. So in the same way that we can take the derivative of a given function, we can take derivatives of derivatives. This will give us information about the rate of change. The second derivative tells us about the rate of change in the first derivative. Okay, so what exactly does that mean? Okay, so let's kind of go over this just a little bit here. So in this case, we have some notation here. If you need to, go ahead and pause this and then push play when you're ready. This is a little bit to write down here. Okay, so we have some notation here. Alright, so f of t. Alright, f of t equals s. ds dt is the rate of change of the position with respect to t. Okay, so WRT stands for with respect to t. And then the second derivative is the rate of change of the velocity with respect to time. Okay, so again, WRT with respect Okay, so the original function here is, again, our position function. So that, again, is f of t. Again, it's the original function. It's the position. Okay. The first derivative, which is the rate of change of the position with respect to time, is velocity. So that, again, this is the first derivative. Okay. The second derivative is the rate of change of the velocity with respect to time. This is our acceleration, again, which is the second derivative. So this is the notation we use for second derivative. So 2 prime marks. First derivative is just 1 prime mark. But let's first practice taking some of these higher order derivatives. So again, double prime here. That means we're going to find the second derivative. In order to find the first derivative, however, we might want to rewrite this. So again, we have a number times a variable raised to an exponent. So if we rewrite that, my number is going to be a half. And then we need to move this x up to the numerator, so we make that exponent negative. So when we take the first derivative, we're using the power rule. It would be negative half x. Decrease that exponent by 1. And then again, we're going to take the second derivative, so follow our power rules again. Multiply. So here we get negative 2 times a half, which is going to be positive 1. Decrease that by exponent by 1. Alright, so let's continue to take the derivative of this function until the derivative is 0. And hopefully, let's think about this. How many times do you think we might have to do that? Why does it make sense Okay, so again, kind of in your head, think about how many times you might have to take the derivative of this until you get to 0. We absolutely can test that theory. So let's start with the first derivative. 10x to the 4th minus 6x plus 4. Second derivative, again, continuing to do power rule. Third derivative. Sorry, I have a typo here. Let me go back and fix that. I just noticed that as I was taking this into account here. It did not decrease that one. Hopefully you guys caught that. Decrease it by 1. I did here, so I got to decrease that one by 1 as well. And then this is the third derivative. Now when we get higher than that, we actually just start writing the numbers in parentheses. We don't no longer use that prime symbol. So again, this is the fourth derivative. So again, we're going to multiply here, 240x. And as you notice, as we keep taking the derivative here, we are eventually getting rid of our variable. Once that variable disappears and we take the derivative of a constant, that is when we get the derivative of 0. So, going back to our original, continue to take the derivative of y until the derivative of 0, we had to take it 6 times. Hopefully that makes sense, because again, when we decrease this by 1 each time, the highest degree, it took us 5 times to get rid of the x and 1 extra time to get down to, again, derivative of a constant is 0. So hopefully that does make sense that it took that many times. Okay. Alright, so that concludes our lesson on higher derivatives. We will address this in a little bit more detail a little later on in terms of the first derivative, second derivative, and third derivative. Original function, first derivative, and second derivative in terms of position, velocity, and acceleration. So please kind of just make a mental note that will come back. Okay? Alright, and that, again, this concludes our notes for higher order derivatives.